Okay, good morning.
Good morning, sir.
Good morning, sir.
Fine. So, as I don't have speakers over here, whatever the doubts or whatever the queries are there, you just write it in the chat box. Okay. See if. Okay. Right. So, today we'll have a new topic, regulated power supply. Right. So, actually, there are two types. One is unregulated and regulated. Whereas unregulated means always the output voltage, the voltage what we are getting is going to be varied. It will not be a constant. So whereas regulated, we will get a constant DC voltage at the output side. That is a predetermined value. Suppose if I want a 5 volts, then continuously if I set my circuit to a 5 voltage, then continuously I'll get the output at the output 5 volts. Now then if I want 10 volts, by adjusting some of the resistance, I'll get a 10 volt output. It is irrespective of the AC mains fluctuations. Okay, it is irrespective of the output what I'm getting is irrespective of the AC mains fluctuations. So whatever may be the AC input means the fluctuations, I will get exact or with very few millivolts variation, I'll get the load output. Okay, it is regulated power supply. Whereas in unregulated power supply, the output changes according to the input. But in regulated, the output does not change. If I set it for 5 volts, continuously I will get 5 volts. If I set it for 10 volts, continuously I'll get a 10 volts, even though if there is a variation in the input. Okay, so a simple block diagram is there for the power supply. Whereas the AC input is being given a power supply, then input voltage to the voltage regulator circuit, two blocks are there, and then what I'm getting at the output is load. At the load resistance, I will get voltage, load voltage. Okay, so this the block diagram is again given in terms of a circuit, whereas this block diagram is going to have a 3 stages. One is a transformer where AC input is given, it is being made towards the downside, or that is a step down transformer, or it may be a step up transformer. Then from this transformer, the bridge circuit is applied here, whereas this bridge circuit is converting the AC pulses in AC pulses waves into a DC pulses, and then filter circuit. Okay, where this filter circuit is removing all the AC components. Filter circuit is removing AC components and allowing only a DC voltage to be to the outside, that is at the load side. Where our load is being connected, we will get load voltage here, VL. Okay, so this transformer stage, then rectification stage, and then filter circuit. These are the 3 stages that we are applying here to get a regulated power supply. Then here some other ICs also we will get, which are going to control the output, which are making the output constantly at a same rate. Now for this power supply, there are some characteristics, right? Some 5 characteristics are there, which we'll discuss now. Okay, the first one, load regulation. Load regulation, or it is also called as load effect. Okay, it is the change in the regulated output voltage when the load current changes from minimum to maximum value, right? When the load current changes from minimum to maximum value, it means when at the output side I the current is flowing, right? I will get the current at the output side. So this is changing from 0 to maximum. Then whatever the changes I am getting at the load voltage, that is called as load regulation. Regularly what I am getting the load, at what range of current, that is changing from 0 to maximum. Okay, then how it is going to be calculated? The no load voltage minus full load voltage, that is from 0 to maximum, that I told now. So whenever the load changes from 0 to maximum of the current, then what is the regular voltage that I'm getting is called as load regulation, right? So this occurs, the load resistance is infinite when uh, we no load, this occurs at resistance is infinite, a high resistance is there, and the V full load, I will get a full load output occurs only when the load resistance is minimum, right? Obviously Ohm's law, when the resistance increases, the current decreases, right? So output voltage is infinite. That is a no load voltage also decreases. When the resistance decreases, current increases, voltage also increases. Okay. So this is what load regulation. Then the percentage of this load regulation can be calculated as the same thing, V no load, V no load minus V full load, okay, divided by full load into 100. That is the percentage, how much it is going to change whenever the current is changing from 0 to maximum. Okay, so this is the load regulation. Then minimum load resistance. Minimum load resistance. What is this minimum load resistance? Is, so whenever a load resistance is very low or whenever it is minimum, okay, the power supply delivers, this power supply delivers its full load rated current at a rated voltage is referred as minimum load resistance. Okay, it means when I'm going to get a full voltage at the output side, then it means that I have a minimum load resistance. Say suppose when I want 5 volts output, right? 230 AC voltage is my input and 5 voltage DC output. Now this 5 voltage is going to change from 0 to 5 voltage, right? So when it is full load, that is full output at the 5 voltage, right? So when I will get the 5 voltage full load, whenever the load resistance is minimum. Whenever the load resistance is minimum. Okay. So this is calculated as V full load divided by I full load. Obviously, the resistance is equal to V by R, the Ohm's law. Again. Okay. Then the source regulation or line regulation. Okay. So that is what the change in the output voltage for a specified range of input voltage. Right? Understand this. The line regulation is defined as the change in the regulated output voltage for a specified range of input voltage. Right? See, the input voltage is AC. Now the output voltage is DC. Now I have set it for 5 voltage. Continuously I should get 5 voltage. That is a regulated power supply. Now, if anything has been changed at the output side, that should be within the specified range of input voltage. This term, if I change input voltage uh, from 0 to 230 volts during that time, what is the change at the output? That change is called as line regulation or source regulation. That is, the regulation is happening at the output side because of the source. That is why it is source or line regulation. Okay. Then the output impedance, right? So the output impedance or load uh, impedance is, this is very small, as we have stated, the load resistance is going to be minimum. The output impedance is going to be very small, so that even though if we change the load external load resistance, almost no change is seen in the load voltage. So the output impedance should be very small so that we should not get any fluctuations in the output voltage. That is output impedance. Okay, okay, it is been written here. An ideal voltage source has an output impedance of 0. Okay, right. Then ripple rejection. So this ripple rejection, in the previously we told that there is a filter circuits, right? So that filter circuit is going to remove the AC components. So like that only, this ripple is equivalent to the variation in the input voltage. If the input is being varied around 200 volts, 180 volts, and again it is going to 230 volts, and again it is coming back to 150 volts. If there is a fluctuation in the input side, okay, that causes to change in the output side, no? So that should be rejected. So thus, voltage regulator attenuates the ripple. Ripple is nothing but, we can say it as a noise. That should be attenuates. Attenuates means stops. Okay, so this voltage regulator attenuates the ripple. So since we are using a filter circuit, and as well as we are using a negative feedbacks, so that the distortion is reduced at the same factor of the gain, right? These are a few simple characteristics are there of this power supply, regulated power supply. Okay, simple it is. Transformer is there, rectifier is there, filter circuit is there, whereas a load regulation is the change in the output voltage when the load current changes from minimum to maximum, right? And minimum load resistance, whereas it should be very much minimum to get a higher output voltage, that is load voltage. Then source regulation or line regulation, it is the change in the output voltage with a specified range of input voltage. Then output impedance, which should be equivalent to 0, where even though if we change any external load resistance, the change in the load voltage should be not, no changes is seen in the load voltage. And ripple rejection, that is whenever the input has been changed or fluctuated, there should not be any or the regulator should attenuate the ripples. Okay, what is ripple? Ripple is a periodic variation. Ripple is equivalent to a periodic variation in the input voltage. That is, variation in the input voltage is nothing but ripple. That should be attenuated by the voltage regulator. That is ripple rejection. So simple 5 points are there, which are very much important. Okay, for this power supply, regulated power supply. Then an adjustable voltage regulator. Now here, as I said, adjustable. So previously I told that here I can make or I can adjust the output as per my requirement. So if I want 5 volts, if I want 10 volts, if I want 12 volts, so according to that, the output should be changed, right? Continuously, but that should be continuously, constant 12 volts. If I set the circuit for 12 volts, the circuit should provide me continuously 12 volts, right? So this is an example for adjustable voltage regulator. So whereas an adjustable voltage regulator is a regulator that can output adjustable voltages from anywhere in the range that the voltage regulator is designed to output. Okay, suppose my this circuit is going to give me a maximum of 15 volts. Then I cannot accept the circuit to give me 20 volts because it is been designed for 15 volts. But instead of asking it for 20 volts, I can make it adjust with the 5 volts or 8 volts or 10 volts, or it may be 12 volts. But maximum it should be 15 volts, not more than that. Right. So this is one example is there by using the LM317. LM317 is one IC. This IC is a voltage regulator circuit. Okay, it will give an output based upon the circuit elements that we are going to use here. So C1 is there, C2 is there, two capacitors and two resistors are connected over here, R1 and R2. R1 is fixed here, 240 ohms, whereas C1 and C2 are 0.1. Okay, two capacitors are there. So basically these capacitors, the capacitor C1 is used to reduce the sensitivity to the input line impedance. C1 is used to reduce the sensitivity to the input impedance. C2 is used to reduce the unnecessary ringing. Ringing means coming back or happening the same twice, thrice, repeating. Ringing is nothing but repeating. Okay, C2 is controlling that ringing. C1 is controlling the impedance, line impedance at the input side. Okay, C1 input impedance, C2 ringing at the output side. So what about R1 and R2? So here the values, R1 is fixed 240 ohms, but the value of R2 is going to be adjustable. So the voltage what we require at the output side, that is going to be depending upon the value of R2 here. Okay, so by placing the different resistor values for the resistor R2 below in the schematic, we will get the voltage adjustment. We can achieve the voltage adjustment. Okay, say for an example, this circuit, the output of this circuit is going to be V out is equal to 1.25 volts, whereas it is a step, the first minimum step that we are going to get 1.25 volts into 1 plus R2 by R1, 1 plus R2 by R1. Okay, so here it's a voltage dividing point that we are going to give here for the adjustable input. Okay, input voltage, we are going to give an input source, connect input source here, we are getting an output side here. C1 is controlling the input impedance, C2 is controlling the ringing problem. Then R1 is fixed, whereas R2 is going to give adjustable voltage at the output side. Okay, so this is the formula that we are getting from this circuit. Whereas, for example, for 5 volts, okay, for 5 volts, now R2 is going to be 720 ohms. It means if I keep, if I adjust this R2 to provide me 720 ohms of resistance, then the output voltage what I am going to get here is 5 volts. Okay, suppose if I make it 1.6 kilo ohms, then the output what I am going to get is 10 volts. And then if I make it 2 kilo ohms, the output what I will get 12 volts. Okay, so this is what called as adjustable. This is what called as adjustable voltage regulator. Hope you have understood. Then I'll go for next topic. Right. So next topic is going to be analog to digital converter and digital to analog converter. Okay. So this is very much important for all of your future. What is the requirement? Why should I convert from analog to digital or digital to analog? So first of all, electrically sophisticated or any high speed processing are performed digitally in the all CPUs or whatever the DSPs. Okay. Can you repeat that? It's, which one? Niaz Ahmed. Repeat what? Earlier. Earlier is what? Say it. No. Adjustable voltage regulator. Yes. Adjustable voltage regulator. Yes. Okay. Fine. I'll. However, these recordings are going to be uploaded in the YouTube channel. You can watch it from there. But right now only I'll clear it once again. Here, what we have seen in the upper side is voltage regulator. Okay, regulated power supply. So fixed voltage that we are going to get from this circuit, 5 volts or 10 volts or 15 volts, continuously the same thing. We cannot make an adjustment over here. But what is Adjustable voltage regulator is this one, where we are using, for an example, we have taken up here LM317 voltage regulator. This is an IC which is having the all these three stages. So like not like a transformer, but it will be having a rectification, and then it will be having a filter circuit, and then regulations. Along with that regulation, filter circuit, this LM317 LM317 is also connected in a closed circuit. Okay, whereas some components that we are using here are C1, C2, R1, R2. So the design is very simple, whereas R1 and R2 are providing us a voltage divider here. Then C1 is controlling the input impedance. C1 is controlling the input impedance, and C2 is controlling the ringing issue. Ringing issue is it's nothing but repeating the same output twice, and it will get multiplied. 2 will become 4, 4 will become 8, so output will be increasing continuously. It should not happen. That is why a ringing issue is reduced by this C2. So C1 and C2 are controlling the input and output variations, whereas R1 is fixed here 240 volts. Then R2 is a variable resistance. R2 is variable resistance. So my output is depending upon the value of R2. My output is depending upon the value of R2. How come? So I have a formula for this circuit, so that output voltage is going to be 1.25 volts of 1 plus R2 by R1. So here, if I change, see, nothing I can change here except the value of R2. If I keep the value of R2 as 720 ohms, then I will get at the output side 5 volts. Now continuously I will get 5 volts. Now suppose, say, if I want 10 volts from the same circuit without changing anything, right? Then I can only change the value of resistance R2 to 1.6 kilo ohms, and then the same circuit will provide me 10 volt output. Now it is continuously it is going to give me a regulated power supply of 10 volts DC. And then if I want more than 10 volts, suppose 12 volts, then I'll just adjust the value of R2 to the 2 kilo ohms. R2 is a variable resistance here. Okay, as I'm changing the value of this resistance, I am going to get the higher output voltage according to this formula, which has been designed for this circuit. Okay, so this is what called as adjustable voltage regulator. The previous one was simple voltage regulator, where output is fixed 5 voltage. I cannot get more than that, or I cannot get less than that. Here, suppose if the maximum output is 15 volts, I can get any value from 0 to 15 volts, or that means I'll not get any voltage more than 15 volts. It should be less than 15 volts. For that purpose, I need to change the value of resistance R2. Is that okay? Okay, fine. If you have understood. Right. I think the time is also up to the end. We will just see why, uh, what actually the requirement of analog to digital or digital to analog conversion is required. Okay. As in the environment, everything is available in the analogous mode. Analog signals cannot be processed with a higher speed. So, but the electrically sophisticated signals can be processed, right, are performed digitally in the CPUs. Whatever the processors are there, they are not going to execute, or they are not going to perform on the analog, but they are going to perform on the digital more, and which are very much high speed. That is why whatever the signals we have in the analog, we need to convert it into digital every time when it is going to be passed through CPUs, or also DSPs. DSP is also a processor called as digital signal processor. Okay, so for each and every time we need to convert the analog to digital. Now, for example, the mic I have, uh, the voice which I am generating is an analog signal that is reaching the mic, and the mic is converting the analog signal into electrical signal, correct? And that electrical signal is given to the processor computer, and that processor is whichever the digitally converted signal it is processing, and then it is transmitting over the communication channel, and then that communication channel you are accessing that channel, then you will get that digital signal. Your computer or your mobile will get that digital signal, then your mobile is converting that digital signal into analog electrical signals again, then those signals are converted back to analog signal, right? Through what we have, through your speakers, electrical signal is being converted into voice signal. So this is what, just for an example, what I said. Okay, so the requirement of analog to digital and digital to analog converter. Okay, so with this we'll continue the same in next classes, right? Okay, fine. Okay, so upload the notes either in HRMS or in the WhatsApp group. Sayeda, I have already uploaded in the HRMS, but students are saying that they are not fetching the notes from that website. Not an issue. I'll send it into the WhatsApp group. Okay. So shall we end the session? Right. You can exit.